Assalamualaikum warahmatullahi wabarakatuh. My name is Nurlana Balkis binti Hairi, metro number AE19005A. I will present about activity 1. Okay, first of all, we need to construct this diagram into MATLAB Simulink. Okay, as we can see, I have already construct the diagram. Okay, the input voltage, we set the value into 240 volt. Okay, and then the km value we put 0.516, the LA value we put 0.0281, and for RA input is 2.581, and for the JM we put the 0.0221, and the BM is 0.002953. For the tachometer constant, the value is 0.065. For the break, we set into 0 and the top constant is 0.05. Okay, let's try run and see the result. Okay, as you can see, this is the graph for input voltage. Okay, this is the graph for motor torque. This is the graph for motor speed. And this is the graph for tachometer voltage. Okay, next, we need to construct this diagram because we need to find the value of input voltage and tachometer voltage by varies the motor speed. Okay, I have already construct into Simulink. Okay, first we set the value is 400. Let's try run. Okay, the input voltage is this is the input voltage at t 10 second, which is 26 volt. Okay, for tachometer output, as we can see, at the 10 second, the value is 26.02 volt. Okay, next for value 800. Okay, let's try run. Okay, at the 10 second, the value is 52 volt, and for tachometer volt output, the value is 52.04. Okay, this is the data that I have obtained from the Simulink. Okay, next, we need to plot the graph for motor speed against input voltage and motor speed against tachometer voltage. Okay, this is the graph that I have obtained from the motor speed against input voltage. Okay, and this is the graph for motor speed against tachometer voltage. Okay. Okay, to discuss the finding of step 6. Okay, both graph is not much different between them. The motor speed is directly proportional to the input voltage and also the tachometer voltage. Next, to calculate the tachometer constant in volt per 1000 RPM. Okay, we get the 3.9 volt per rad per second. Okay, for the learning outcome from activity 1, we have learned that the motor speed is influenced by a tachometer constant, the input speed, and also the input voltage. Other than that, the steady state of the input voltage and tachometer voltage are simultaneously constant at every rotation per minute.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Akila Alia binti Abdul Rahim. Today I will present for activity 2. Activity 2, as we can see here, is the block diagram setup. And then firstly, we have the input voltage. Input voltage here is 162.5 volt, and then for the break scale 0, we need to run the MATLAB, and we will get the motor speed is 2502 RPM. After that, we need to change the brake scale to 3, and after we run, we will get the motor speed in RM, which is 2271. After that, brake scale 6. For brake scale 6, we will get after we run, we will get the result, which is 2040 RPM. As we can see here, we will change from 6 brake scale to 9 brake scale, and we run the MATLAB reading 1809 RPM for the motor speed. We need also to change from 9 brake scale to 12 brake scale, and then we run the block diagram, and we will get the result 1578 RPM. And then we change to 15. After we change to 15, we will get the reading 1347 RPM. For the second last, we change the brake scale to 18 and we run the system and we will get the reading 1116 RPM. And lastly, for 21 brake scale, we will get, after we run, we will get the reading 884.6 RPM. So in conclusion, if the brake scale is higher, so the motor speed for the system will become lower.
Assalamualaikum warahmatullahi wabarakatuh. My name is Norazata Akmal binti Muhammad Kamal and my metric number is TE190154. Today I will do the simulation for the activity number 3, which is closed loop speed control system in this lab activity. So let's go. Now this is activity number 3, which is closed loop speed control system. So this is the block diagram that I've been set up in MATLAB by using Simulink. Okay, after that I have been construct and set up the parameter by using the table in the 8.1 and also 8.4. So first of all, I have fixed the voltage input at here, which is the voltage input at here is we set as 162.5 volt at here because of from activity number 2 we observe the voltage input is that, so we set it here. After that the time sampling is 10. After that, okay, and set the value of brake at here is 0. Okay, first of all, before we start in this lab activity 3, we will observe the motor speed value for a different brake scale. So we're gonna change the brake scale at here, which is from 0 to 21, and we will observe the speed output at here. Okay, now we run the simulation. After compiling, double click at the speed output. Okay, as we can see it here, this is the graph of the time versus the motor speed at here, which is RPM. So as you can see, the RPM, okay, the RPM for brake scale is 0, which is no load. The motor speed is 2488. Okay, after that, we change the brake at here. Same goes to the different brake scale at table 8.5, which is next is 3. After that, run the simulation. See the graph which is the motor speed in RPM, as you can see and observe from this graph. Okay, we get the output for brake scale is number 3 is the motor speed are going to increase. It's down to 2486 RPM. So with the same step at here, we're going to change the brake at here to the 6, 9, 12, 15, 18, and also 21 to get the speed output. So this is the result of the speed output after change the brake from 0, 3 until 21.
So activity number 3, as we know, the closed loop system, control system are having a feedback. So it's try to maintain the motor speed, which is 2500 RPM. So from scales brake at 0 until 15, it's try to maintain the desired value. So after it's going to be a overload, so the motor speed will be increased until they are having a overload, it will be stopped. But for activity number 2, which is the open loop control system, okay, there are no feedback, so it can reduce error to get the desired value. So as you can see, if we increase the brake scale, the motor speed in RPM will be decrease.
In conclusion, by completing exercise 8, students are able to learn regarding the open loop and closed loop system. By completing the activity 1, students are able to observe the input voltage and tachometer voltage for different motor speed. Next, by completing the activity 2 and activity 3, students are able to observe the input voltage and tachometer voltage for different motor speed. Lastly, by completing the all activities, we are able to design the block diagram in MATLAB software. That's all from our group. Thank you.